What do you understand by relation? Let's start with relation. Anybody? Relation, what does that mean to you? Yeah, anybody? Relation? With the light outside, can you still see my face very well? Hopefully. Yes, relation in maths. Okay, relation in maths. Just give me any idea, connection between one thing or the other. Good. How things are related. Yeah, you're right, you're right. How things are related. Connection between one thing and another. Clarissa, can you give an example in math um, to buttress your point that relation is a connection with one thing to another? And like relation between two variables, give me concrete example. Clarissa, you're right. Give me concrete examples. One example is sufficient. And maybe with Mike, so we can have that on the recording as well. You're still saying the same thing. How A and B are related. Yes, your mic is broken. Okay, I understand now. How A and B are related. Give me example. You're still explaining. You haven't given me example. You're right, actually. Anyone? Examples of relation. Mr. Chen, you were going to say something?
X equals Y.
X equals Y. Yes, that's a relation between X and Y. Can we have more non-trivial relation, particularly maybe in real applications?
2 plus 5 equals 7.
Okay, Clarissa gave that relation. Now, Clarissa, I'll come back to you, Ethan. Clarissa, what is this relation that you have given? She wrote a squared plus b squared equals c squared. That's a relation between a, b, and c. That's the Pythagoras theorem, isn't it? Ethan Cheng, you mentioned something just now. Could you repeat that?
2 plus 5 equals 7.
2 plus 5. No. This is not a relation. I thought relation is the relationship between two things, two variables. You're just giving us numbers.
Oh.
Yeah. You said x equals y. I said yes, because we are talking about how x and y are related. Yes, that's allowed. Can you give me something like that?
2x equals 3y.
Okay, still giving us equation. 2x equals 3y. Okay, we take that. So basically, let's come to the board. Ooh. Just a sec, setting up. So today is Monday. So I don't want to write too much objective, so I think it will just be about function, relation, domain, and range for today. I think it should just be about function, relation, and range for today. All right. So we just make it short, so I can understand the basics. All right. So you have given us various explanation. Well done. It makes so much sense, everything you have said. Okay. So a function, a relation, sorry, it starts from the relation. A relation, like you said, is connection between two variables. Okay, two variables. So in this case, we'll be just using X and Y, basically. Let me open my chat box so that when you say something, just without mic, then I can pick it up immediately. Clarissa said like a relationship between two variables. Yeah, but Clarissa, in the example you gave three variables, so but that's all right. I'm just going to assume the third one is not a variable. Ethan mentioned examples like 2x equals 3y and so on and so forth. So what is a relation? Let's write. What is the mathematical definition of a relation? We'll discuss that. We'll be looking at what is a function. Trying to combine two different ideas together. That's why. Okay, I think I will use this simple one. That's right. Relation R. I'll use R. R to not the scripts, just normal R. The script one is a set of real numbers. All right. Relation R is a set of ordered pair. Ordered X, Y. Okay. Such that X belongs to A, Y belongs to B, such that X belongs to A, Y belongs to B, for empty sets A and B. Have you taken note of that? Okay, so what do we mean by this? If you have if you have X, let's see, Y equals, like equation of the line now, okay? This equation is a set of points. Do you agree? There are actually infinitely many of them. When X is 0, Y is what? Talk to me. 1. When X is 7, Y is There's so many of them. When x is -3, y is -5. So you can see that you can have infinitely many of this ordered pair. Can somebody tell me what we mean by ordered pair? Anyone? If you have a mic, please turn it on. Unless there's a background construction, that's the only time I need you to type in your response, please. Can someone tell me what I mean by ordered pair? No idea? Let me know if you don't have any idea or if you're just thinking about it.
Is it like it goes in the order, like the XY order?
You're still using the word order. The problem I'm having is I don't know what order pair means.
If it's like bracket 2, 3, then it would mean that 2 equals, like 2 is the X and then 3 is the Y.
Okay, that's still, yeah, I know that 2, 3 means this is X and this is Y. So why do we need ordered? I could just say the relation is a set of X, Y such that X belongs to non-empty A, Y belongs to non-empty B. Why do I have to say ordered pair? Anyone? I get what Lillian is saying. This means this. It means X is 2, Y is 3. So the point is, if I do not use ordered, does that mean this definition is wrong? The relation is a set of X, Y such that this happens. So why can't I just, why do I have to use the word ordered? It is ordered because the order is very important. That's what it means. The order is very important because it's not the same if you change it otherwise. All right? So it's not the same when you change it. 2 and 3, 2, 3 is not the same as 3, 2. Am I right? Yeah? So when we use the word ordered, we mean that these positions are important. And the moment they are altered, you are talking about something else entirely. So this combination, set of points, remember the set of points is what forms this, okay? That's why this is the relation between X and Y, okay? Because it's the set of points, set of ordered pair, okay? Such that X belongs to a set and Y belongs to another set. For example, -3, 0, 7 belongs to a set. So this is my A, of course, and many more. Then my B will be -5, 1, and 15. So it's a set. Okay, so A cannot be empty, B cannot be empty, and any other pair that you find such that A belongs to this and B belongs to this, the combination of all the other pair is a relation. So for example, let's put it this way, let's put it in context, e.g. Y equals 2x plus 1 is a relation between X and Y, right? Okay, because R, that's the relation R, contains, what does it contain? It contains something like when X is 0, when X is -1, Y will be -1. So this is R, it contains, sorry. It contains -1, 1, -1, -1. Contains 0, 1. It contains maybe 3, when X is 3, Y is 7, etc. It contains ordered pair. So R will be the relation R. Remember, the relation is a set, so I'm going to write it properly now. So my R is this set -1, -1, 0, 1, 3, 7. Remember, R will be an infinite set this time around, unless I restrict what my A is and what my B is. So this is a relation. You can see my A in this case. Yeah. Somebody tell me the elements in A and the elements in B in this example. Yes. What's the element in A? Yes, I need you to say something even if you don't understand, so I know what is missing. So Clarissa says -103. Yes, Clarissa. So those are the elements in A. -103 in order. I like to put it in order. So I follow your own answer. -103 continues in this case, and similarly, B will be -117. And I just pick a few points on the line. Questions? I need yes or no. All right. So a relation is an ordered pair. Okay. It's an ordered pair XY. It is ordered because the moment you interchange it, you're talking about something else entirely. Okay. The X comes from a set, Y comes from another set. Okay. Any questions on that? So from relation, let's move to the idea of function. Okay. So now, not all relations are functions. That's the point we're trying to make. Okay? Not all relations are functions. So the question is, when is a relation said to be a function? All relations are functions. Okay. So we can ask ourselves, so when exactly is a relation said to be a function? Okay, so that leads to the idea, the definition. What is a function? If your textbook is with you, although I'm using combination of two or more, I'm using this one, the book one, the core, page 395. You can find it on page 395. Okay. So a function, should I say a relation is a function? It is first a relation before it qualifies to be a function. The relation is a function if no two x coordinates, okay, if no two y coordinates have the same x coordinates. I think that's the easiest way to look at it. If no two, if no two other pair, in your textbook it says if no two other pair have the same x coordinates. So I said if there is no two x coordinates, no two y coordinates have the same x coordinate. For example, this is minus 5, 3, and this is also minus 5, 2. Then you don't have a function here, okay? You don't, because you can see when x is minus 5, you get 3. When x is minus 5, you get 2 again. Then this is not a function. So let me use, I'll take different definitions. I'll put the locus two that I mentioned now. If no two y coordinates, if no two y coordinates appeared with same x coordinates. Let's put it that way. Two y coordinate appear with the same x coordinates. Say if no two other pair, okay, if no two other pair, can I say distinct other pair? If no two distinct, because they have to be different, right? If no two distinct means different, ordered pair. By ordered pair, you know I mean xy, right? If no two ordered pair have same x coordinates. Okay. Another way we could say it is this, or according to another material that I have here, if every x value has a unique y value. That's another way. Or if every x value has a unique y value. Talk to me, everyone, if you get the message here. Understand? So you can have a relation, but it doesn't guarantee that you have a function. That's the point here. So I'll go again. A relation is the set of all the other pair such that the x coordinate is from a non-empty set, the y coordinate is from a non-empty set. Of course, the two sets can be equal, we don't care. The two sets can be distinct, we don't care. But if A and B are non-empty sets such that x is in A and y is in B, then you have a relation, okay? We have a relation x comma y. The set of x comma y forms a relation, okay? Now, when is this relation said to be a function? If for every x, there is a unique y. That is, if you have 2, the y is different. For another, when you have a 3, you cannot have x is 2 and y is 4. Then you have x is 3 and y is another thing else. Remember, a unique y for every x. We are not saying a unique x for every y. We're saying a unique y for every x. So you pick an x, there is a unique y. You pick another x, there is a unique y. You understand that now? You can't have for one particular x, different y's. You can't have that. For example, you're having 2, 3, then you're having 2, 8. That's not when you collect those points together, you don't have a function. But you have a function if when you have this unique y for every x, the collection of points you put together is a function. Another way to look at it is to say that there is no two distinct ordered pair with the same x coordinate. I think that's actually one of the simplest way to look at it. There is no two distinct ordered pair with the same x coordinates. Once you can guarantee that, then you have a function. Any questions, please? Okay. Now this leads to any questions? Can I get some response? No. All right. Now this leads to the idea of domain. You see the point, the set where all this x comes from is called the domain of the function. Okay. Where we bring out all the x is called the domain of the function. And where the y's come from is called the range of the function. Okay, so let's move to the next slide and put that right in. Just right below this one, okay? Maybe like a paragraph. It sets the x values is called the domain of the function. Okay. While the sets of y values is a range of the function. Now, what notation are we going to adopt for the class? It's possible you read some materials and it's slightly different, but this is like one of the general notation that is used. Let me check. Your textbook doesn't seem to have that. Domain and range. No, they just write domain. All right, so we're going to be adopting a notation here. If f is a function now, okay? If f is a function, symbol d subscript f, can you see that? D subscript f represents the domain. Said this will be seen in so many materials, but it's not the notation used in your official textbook. While subscript f represents the range. So when I ask you to find domain and range, you can write something like domain is the set, range is the set. Instead of writing domain is equal to. Does that make sense? This notation can be used. So in terms of symbol, we can write F with double column, DF Rf means f is a domain, f is a function, sorry. With domain df and range Rf. So when you see this symbol, we're saying f is a function that acts on the elements on df to produce the element on Rf. So for example, when you write f of 2 equals 7, okay? So this 2 belongs to the domain, this 7 belongs to the range. Am I making sense so far? I'm trying to take it slow because some of these ideas are new to us. So I'm trying not to be too fast with this notation. After today's class, we might be faster than this. But for today's class, I don't want us to be too fast. Okay? All right. So like remember I said something here that f acts on this, right? F acts on 2. 2 belongs to this set. F acts on the element here to produce this. We can also sometimes call this element the argument of the function. Okay? The argument of the function. So you can take note of that. So by argument of the function, we're talking about the independent variable x that produces that. Does everybody know what I mean by, so do you write like F27? No, you don't write that, Krista. We only write, good question. We don't write F27. No, we don't write that. We just say F, this is a set. This has to be a set. These two are sets, not elements. Okay, these two are sets. So for example, you can say, if you have a function, maybe R to R, it means something like this. If f of x equals maybe 2x plus 1. Of course, we can say f is defined in this way, such that we have this. Okay, so this is a set. This is a set. It means all the elements that can be used are in R, and all the elements that can be produced are in R. In that case, you wouldn't, can I say, question, for this definition, can I say f of 2.5 equals 6? Guys, answer that question. Can I say that? Krista said yes. Lillian said yes. Okay, good. Yes, you can say that. Now, what if my function, this time around g, okay, takes elements from n to z, okay, and g is defined as dx minus 20. Okay, 3x minus 20. Which of this makes sense and which does not make sense? G of 2, -14. G of 1, G of 0, be -20. G of minus 3, -29. Which makes sense, which does not make sense, and why? You can talk to the mic. If your mic is not broken, that's better. Which of this makes sense and which does not make sense, and why? Yeah. Second one, really? Yeah. Which of this g is equal to 0? I don't know what you mean by g is equal to 0, Ethan. Just and talk to the mic, please. Come on, guys. Which of this makes sense and which of this does not make sense and why? I'm talking about this. We are in this now. All right, so we need to explain. Remember, I asked for two things and you just wrote something. So I don't know which. When I ask you, who do we get, which of this makes sense and which of this does not make sense? You can't just tell me a pen. Are you saying a pen makes sense or a pen does not make sense? So you need to learn to answer questions before you lose points. If I was awarding a live score now. Clarissa, you still haven't answered my question. I don't know if that's why means for the make sense or for the does not make sense. My question is, which of these makes sense and which one does not make sense and why? You're on the right track, Clarissa. You just have to retrace your step and answer the question properly. The question is, which of these three makes sense and which one does not make sense and why? Karen, you said O. O what? Oh, that's the N. So you haven't answered my question. I'm waiting, please. Does that mean everybody has construction going on in the apartment? The second and last one don't make sense because -3 does not belong to n and 0. Okay, this doesn't make sense. You see, Clarissa, this is what I expect you to say. Okay, looks like you gave everybody the idea, but you didn't say it. This is what I expected to say. I wrote that up. What's up? That's not what you wrote. You wrote g equals -3 equals -29 because -3 is not a natural number. My question is, are you saying it makes sense or it does not make sense? Did you get the point now? Yeah, you have to be specific. I'm giving you two choice question. You are saying something, and to me, I don't know which parts you want me to categorize your answer to. I'm not going to assume I know what you're saying. I'm not going to assume that's what you're saying. You need to, right? You need to say it. Oh, this makes sense because of that. This does not make sense because of that. Because I gave you two choices. Which of these makes sense and which one does not make sense and why? Does that make sense? That's how I phrase the question. So please, you guys need to stop giving me short answer, all right? You need to be detailed, particularly when it can be, your answer can be ambiguous, you know? To avoid any form of ambiguity, you need to give a straight answer. So yes, this last one does not make sense, and this also does not make sense because the domain is a set of natural numbers. This -3 and 0 do not belong to n. Okay, so even though -3, -29, and 0, -20 belong to the relation. Okay, but yet G is not your G. Your G is a function, but this cannot be are considered as part of, as what is valid for the function, okay? It cannot be considered. Now, what if I said this is n, defined by this? Is this a function? Think about that. Karen, are you sure? But Karen, these are not natural numbers. Look at this also. Is this a function, guys? And why? If no, why? I'm looking at your response, Lillian. I'm waiting. I believe you are about to complete your replies. Others also, please be part of the contribution, be part of the discussion, I mean. If anyone is confused, speak now so that we can clear things up before I move on. So today is just introduction about all this because I don't want us to move too much. Yes, ask your question. Okay, can I ask the question again? Is this a function? F of x defined as x squared plus 2. Is it a function or relation, and why?
For x, for different x's, you might still get the same y, so it's not a function.
Can you be specific?
So for like, if you have a negative, wait, let me think.
We're waiting, sir.
Because with a negative number, if you square it, it'll become positive.
Be specific. You have learned proof by what? Counterexample. So if it's not a function, just give me a counterexample to disprove it. Don't go
If
in.
x is 2, y will be 6. If x is negative 2, it'll still be negative 6. It'll still be positive 6.
That's all you have to say. That's all you have to say. So for this, you have negative 2, 6. It's a point, right? Then 2, 6 is also a point. Clearly, you can see that it goes against this rule.
But then why do we have things called exponential functions?
What?
Because for like, wait, yeah, for there aren't there also some functions with like squares and stuff? Those are also called functions.
If you can give me an example, then I can tell you if it's a function or not.
Like the sine wave and the cosine wave.
Give me the function.
Don't we call those functions?
Give me the function, sir.
Huh?
Give me the function. Y equals what?
I don't know how to say it, but like, aren't there also some lines that are waves that we also call functions?
Lines that are waves, like this?
Yeah.
This is like sine x. Is that what you mean?
Yeah, yeah.
So is it a function? Last time I checked, between 0 and 30, within a particular range, Yes, you can have them. Because now remember, if you pick any x, you can't have the same x giving you 2y. If I pick an x here, this is the only y I can get. There is no other y somewhere else. Right?
Yeah.
So it's a function. Do you get
Okay. Okay.
understood?
Yeah.
So for every x, you can have two y, and you can have like for different x. So if I put a range like maybe from 0 to 360 or from 0 to 90, I can restrict it. Sometimes if it's not a function, you can actually have a restriction on the domain. So the point is, on a particular domain, given a particular domain, can you have a function? Because for the one you're talking about, it's possible when you extend the domain, you can only, look at what Lillian said. The wave is only not a function if it is rotated 90 degree right. Rotated 90 degree.
Oh, okay.
You see? So if you can restrict your domain, then you are fine. Okay? So look at that. So if I restrict it from here to here, then I'm okay. Okay, but the moment I go beyond, then I'm gonna have two different x's with the same y. Okay, so we can have a restriction on the domain. Good question. I like how why you brought that up. So does everybody understand why this is not a function? Okay, because you can have 2 points. Okay, 2 points here, such that you have the same image. You have the same image for these pre-images. By the way, that's another term. Image, pre-image. The image is y. The pre-image is the x. That is what produces the image. Okay, so you can see that for two different pre-images, you have the same image, or for two different x values, you have the same y value. So this is not a function. Okay, so please take note of some of this. Now, when exactly do we have a function we have mentioned? So let us write two conditions that you need to look out for. When is a relation said to be a function in general? A relation, so it's just a continuation of this. So maybe I erase this part. We don't need this part. Everyone, please signify if all is well so far. Everything like I understand so far. Some of this can be confusing, I know, at first, but with time, you get better. All right, question. Okay, all right, good. So let's so the two conditions that I'm going to write, of course, the first one is the fact that you can only have a function, like we said here, if you have oh, sorry. Oh, yeah. I think my OCD is too much. But compared to Nakita, mine is still moderate, I think. All right. Even Lillian is worse sometimes. OCD is good. Yeah, Karen, Lillian, come on, guys. We can do better. So, two conditions that we're going to be writing. So, a relation, so I write it this way. A relation is a function. I mentioned something about argument. Please don't forget. So, we can also call this two. It's an argument of the function. So in summary now, this now. In summary, f is a function with domain df and range rf if one, f acts on every element in the domain. Just write f acts on every element in df because you already mentioned that is the domain. We don't have to waste time writing domain. Okay. And 2, if f is well defined. Now, question, anyone? Before I move. Something that is not clear, something that is, you're not. What question would you have for me here? Yes. Does everybody understand what I've written? Understand? Okay. So Callista or anyone, what does it mean? What does it mean to say f is well defined? Everybody understands, so nobody should say, I don't know what that means. So if you want to check if a relation is a function, these are the only 2 conditions you need to concern yourself with. First one, check if f can act, that is, can take an argument from the domain, from every point in the domain. Okay, and 2, f is well defined. What does it mean to say a function is well defined? Well defined, actually, we are still talking about in the domain. So I'm waiting. What does that well defined mean? Like the range is not undefined. Okay, more. There is an exact value. Okay. More. Mathematically, when we talk about a function being well defined, this is what we mean. Let's see, this is what it is. Well, say that again.
Every x value has a unique y value.
Yeah. Every x value has a unique y value. That's the well-defined thing. That is, whenever f of x1 equals f of x2, whenever f of x1 equals f of x2, x1 must be equals to x2. Okay, that is the only condition, or let me put it this way, or if x1, y, or if given, let's say given, if that is, or given x1, comma y, and x2, comma y. Can you see the same y? Okay. If you have this situation, given this, then x1 has to be equal to x2. That is, anytime the domain, the elements from the domain are the same, it can only be that the same element was used again, which means there is no way you can have different elements resulting to the same domain. That is what we mean by well-defined. Any question? This idea of well-defined, I still use it till today. Yeah, when we define a function, maybe during some of our proofs, one of the things you want to establish is that, oh, this is actually a well-defined function. This function is well-defined. You want to be sure that it satisfies this condition. Does everybody understand this condition number 2, particularly what I've written here? Whenever f of x1 equals f of x2, it must be that x1 must be equal to x2. Remember, this f of x1 is the y we're talking about. Okay, the y I'm talking about here. The coordinate xy simply is x comma f of x. You agree? So when we talk about f of x1, we're actually talking about the y coordinates. Does that make sense? So whenever we have this, it must be that they are the same. It's the same as what we said here. It's not different. It's exactly what we said here. Okay? So these are the criteria, the 2 main criteria you need to be on the lookout for if you must check for a function to be indeed, for a relation to be a function. So I'm going to put some questions now. I need you to tell me if these relations are functions, and whenever they are functions, I need you to write down the domain and the range. Only write down the domain and the range if they are functions. Okay, are we ready? All right. Okay, so try this problems. So again, for the activity, so the question is, determine okay, with reasons, of course. Let me plug in here and put your level from there. Whether the following relations are functions. If they are functions, state the domain and range. So the first question, -2, 0, -3, 3, -4, 8, 0, 0. So remember, it is a function, you tell us why. It is not a function, you tell us why. And if it is a function, Find the domain and range. So the relation is -5, 1. No, 5, -1 actually. Two, 5, 3, 10, 4. Y equals 4 minus 3x. Lillian, the question on sign, this is where we can restrict it, okay? It's a function, then we have to state the domain for which it is defined as a function. Is that understood, Lillian? All right. 4 y squared equals x. Number 5. Okay. Yes, Mr. Chang. Oh, so sorry. Someone should have reminded me. Today you have business. What time is it? What time is your business class? 3:30. All right, so we're gonna leave in 3 minutes. Okay, 3 minutes. We go. Someone should have reminded me. I'm so sorry about that. We leave in 3 minutes. All right. I wanted to stop at 3. I mentioned that last time. Yes. Waiting. If we are not able to complete it, then that's fine. All right, so we're going to stop here now. We will continue tomorrow when we meet. Okay, please have a look at this and I'll see you tomorrow. We're going to stop here because of those going for the business class. Apologies once again. Please, next time someone should please remind me if, particularly if I had made a promise to stop the class earlier. Okay? Anyone? Any questions? Talk to me. Can you all hear me? All right. So, all right. No questions so far. Okay. So, and if you observe any error, please bring it to my notice. Maybe when we come next time, I'll address it. It's possible I mixed things up or I did some error in typing or writing on the board. All right. So anyway, so we're going to stop here now. Good luck with your business class. Sorry, you only have 10 minutes before your next lesson. Sorry once again. All right. See ya.